All right, today in geometry, we're looking at section 3.4, classification of rigid motions. Our essential question, how can rigid motions be classified? After today, you should be able to identify different rigid motions used to transform two-dimensional shapes. So let's recall what a rigid motion is. Remember that a rigid motion preserves length and angle measure. So we're going to start out with theorem 3.3. It tells me that the composition of two or more rigid motions is a rigid motion itself. So if I have this picture and I start out with QRST and I transform that to Q prime, R prime, S prime, T prime, and then I transform that to Q double prime, R double prime, S double prime, and T double prime, that those are rigid motions, then the composition of N and M from QRST to Q double prime, R double prime, S double prime, T double prime is itself a rigid motion. So we're going to explore what's called glide reflections. So this says, is there a rigid motion that maps triangle ABC to triangle A prime, B prime, C prime? So let's look over here. Notice in the picture, let's look at the length of AB. Is that the same as the length of A prime, B prime? Notice that it's a diagonal line, so I would have to do Pythagorean theorem. So if I made this triangle, it's up 3 over 2. If I come over here, again, up 3 over 2. So yes, that is equal. B to C, I can count my squares. 3, so BC is equal to B prime, C prime is also 3 squares, B prime, C prime. And then AC, the length of AC down here is 2 units, A prime, C prime, 2 units. So AC is equal to A prime, C prime. Let's look at the measures of the angles. Okay, so I'm going to get rid of those lines that I just drew. So look at angle A and angle A prime. Angle B, B prime, C, and C prime. We notice that they are the same. So the measure of angle A is equal to the measure of angle A prime. The measure of angle B is equal to the measure of angle B prime. And the measure of angle C is equal to the measure of angle C prime. The length and angle measure were preserved. Therefore, I have a rigid motion. So is there a rigid motion that maps triangle ABC to triangle A prime, B prime, C prime? Yes, because length and angle measure have both been preserved in order to get from triangle ABC to triangle A prime, B prime, C prime. So then the second part says, does a reflection, a translation, or a rotation map triangle ABC to triangle A prime, B prime, C prime? So let's check for the reflection because that's the first thing that they asked me. So if I'm checking for a reflection, remember that I would have to find the midpoint between A and A prime. So I'm going to look at midpoint of A and A prime. So let's see, A, let's list our coordinates. A is at -5, 1. A prime is at 3, -4. So my midpoint, remember I add my x's together, so I would have -5 plus 3, -5 plus 3, cut in half, 1 plus -4, cut in half. So I get -2 cut in half and -3 cut in half. So my midpoint here is -1, comma, -3/2. Right, so now let's find the midpoint between another set. It doesn't matter if I do B, B prime or C, C prime, so we'll just do B, B prime. So let's see, B is at the point -3, 4. B prime is at 1, -1. So the midpoint there, -3 plus 1, cut in half, and 4 plus negative 1, cut in half. So I get negative 2 comma 2, or divided by 2, and 3 halves. So again, I get negative 1 comma 3 halves. So that is my midpoint. So if I look and I go ahead and I plot those points, so negative 1 up 3 halves, about right there. Negative 1 down 3 halves, I'm about right there. Notice that that would be a vertical line if I connected those. Okay. Do I have a reflection from A, B, C? If I reflect over that vertical line, am I going to be at A prime, B prime, C prime? No. So no reflection to get there. So next we're going to check for a translation. So we're going to check the translation. Remember, a translation is simply moving left or right, up or down. So if I take point A, to get to A prime, I would have to move 1, 2, 3, 4, 5, 6, 7, 8 spaces right, 1, 2, 3, 4, 5 down. So 8 to the right and 5 down. And that would have to work on all of them. So if I start at B and I move 8 to the right, 1, 2, 3, 4, 5, 6, 7, 8, 5 down, 1, 2, 3, 4, 5. I'm way over here. I'm not at B prime. So no, there is no translation. The last thing that we're going to check for is rotation. So let's check for a rotation. Rotation, remember that my orientation would be the same. I notice right off the bat that the orientation of my triangle is not the same, right? So if I were to rotate this triangle, okay, 90 degrees, A would be down here, but B would be over here. Rotate it again, my B would have been down here instead of up there. So I can easily see that there is no rotation because my orientation is not the same. So orientation was not the same. So in order to get from triangle ABC to triangle A prime, B prime, C prime, it was not a single translation, a single reflection, or a single rotation. So the next question asks, what is the composition of two rigid motions that would map triangle ABC to triangle A prime, B prime, C prime? Okay. So I notice triangle ABC has clockwise orientation. Triangle A prime, B prime, and C prime has counterclockwise orientation. We found up here that if we were going to have a reflection, that it would have been this vertical line, x equals -1. So let's go ahead and reflect it about that line and see where we would be. So A, okay, I am, let's see, 1, 2, 3, 4 spaces over, so I would have to be 4 spaces over this way. This would be my new A after I've reflected. C is 2 spaces, so it would have to be 2 spaces. This would be my C. And B is also 2 spaces. This would be my B. So this would be after I reflect about the line x equals -1. And then I can see my orientation is the same, so then it's just a translation down. So I have a reflection over x equals -1, and then a translation, and let's check that. It's a translation. I don't have to move left or right any because my A's in the same spot, B and C. I just have to shift down. So how many vertices or points do I have to go down? So let's see, to get from here down to A is 1, 2, 3, 4, 5 points down. So I just have to go translate down 5. So the composition, remember that we write our compositions where the first one that we write down is the last translation that we did. So the last thing that we did was our translation. So capital T for translation. We didn't go any left or right, so that's 0. We went down 5, -5, close our parentheses. Open dot for composition. Then we did a reflection, capital R. The subscript is what we reflected about, which was the line x equals -1. Parentheses, what did we move? Triangle ABC equals, what did we get? Triangle A prime, B prime, C prime. So that is the composition of the two rigid motions that would have mapped triangle ABC to triangle A prime, B prime, C prime. All right, next page. The composition of a reflection followed by a translation in a direction parallel to the line of reflection is a rigid motion called a glide reflection. This is another vocabulary word. You will see this on your test on Monday. So the composition of a reflection followed by a translation, it will always be that order in order for it to be a glide reflection. So we're going to look at finding the image of a glide reflection. So in this problem, it says a digital artist is reproducing a tire tread pattern from a partial tire print from a crime scene by applying a glide reflection. She uses the rule translate 0,0.1 composition reflect of the y-axis to generate a pattern. Confirm that her rule can apply to the partial pattern that was taken from the crime scene. Okay, so step number 1, apply the very first rigid motion. So in this composition, that is going to be the reflection about the y-axis. So here we see that we have the tire print. So let's go ahead and draw an XY axis. So X, and then we will make Y down here. So there's my XY axis. I'm going to say this is my figure right there. There's the pattern that I see in that tire. So first thing is to reflect over the y-axis. So that's going to come this way. I'm going to reflect over the y-axis right there. Step number 2, apply the second rigid motion. So this is translate that now, 0,0.1. So let's say that this is 0.1. This would be -0.1. This is also 0.1. Right? So we're just going to go ahead and add those on there. So I'm going to take all of this and I'm going to move it up 1 unit. So this now becomes here. So there's my new translation. Right? Do I get on that same pattern? Yes, I do. So yes, it appears to map the pieces of the partial pattern to itself. So yes, the composition of rigid motions that she came up with, her rule, appears to work in this. All right. Quadrilateral RSTV has vertices R -3, 2, S 0, 5, T 4, -4, V 0, -2. Use the rule, translate 1, 0, composition, reflect x-axis to graph and label the glide reflection of RSTV. So the very first thing I want to do is the reflection of the x-axis. I'm going to write down now R prime, S prime, T prime, and V prime. Remember that if we are reflecting on the x-axis, what changes? The y value changes. So my x stays the same, my y's become the opposite sign. So R prime is going to be -3, -2. S prime is going to be 0, -5. T prime will be 4, 4, and V prime will be 0, 2. Now I do the translate 1, 0. So again, I'm going to have R double prime, S double prime, T double prime, and V double prime. So my translation, my Y's are not going to change. My X's, I need to add 1 to each of them. So -3 plus 1 puts me at -2, -2. S double prime, 0 plus 1 puts me at 1, -5. The T double prime, so 4 plus 1 puts me at 5, 4. And the V, 0 plus 1 is 1, 2. If I plot these points, I should have my glide reflection. So let's plot those points. -2, -2. 1 negative, and that is R double prime. 1, -5. That is S double prime. 5, 4. T double prime, and 1, 2, V double prime. Let's connect them. In class, I will provide you with patty paper that you can go ahead and plot the original RSTV and then reflect over the x-axis and then do the transformation and make sure that it lines up with where we're at. Okay? All right, so now, next page. Theorem 3.4 tells me any rigid motion is either a translation, a reflection, a rotation, or a glide reflection. So if M is a rigid motion, then M is either a reflection, or a translation, or a rotation, or a composition of a translation and a reflection. The corollary to Theorem 3.4 says any rigid motion can be expressed as a composition of reflections. So if M is a rigid motion, then M equals the reflection, or M equals the reflection with a composition of another reflection. So we're going to determine a glide reflection. So here it gives me this picture. It says, what is the glide reflection that maps triangle JKL to triangle J double prime, K double prime, L double prime? So step 1 says determine the translation. Step 2, determine the line of reflection. Remember that we're going to have a translation first, then a reflection. So we want to find out what is that reflection first, right? So I see that first off, my orientation has changed. Since my orientation has changed, I know that when I reflect triangle JKL, K has to come down here and J and L have to go up. So that tells me that I'm going to be reflecting over a horizontal line. So I need to find that horizontal line to get the same orientation as J double prime, K double prime, and L double prime. So let's find out. Okay. J was at the point -5, -2, right? -5, -2. J prime is at the point 0, 4. If I'm reflecting about a horizontal line, they would have to be the same distance from that horizontal line. So I'm only looking at my horizontal, okay? So look at the Y values. So from J, my Y is at a -2, the J prime at a +4. So what is the midpoint between that? So the midpoint there is -2 plus -1 cut in half. -2 plus oh, sorry, that was a 4. -2 plus 4 is 2. 2 cut in half is 1. So that tells me that Y equals 1 is my horizontal line of reflection. Okay? So now I'm going to go ahead and do that. I'm going to reflect triangle JKL over that. And so that would give me, this is where K prime would have been. This is where L prime would have been. And this is where J prime would have been. So now to find the translation, I see that I'm not moving up or down any, so there is no vertical or Y translation. So I simply have to move to the right. Let's see, 1, 2, 3, 4, 5 units. So right 5 units. So write the glide reflection. So I start with the translation because that's the last one we did. So capital T, 5, 0, composition, my reflection about the line y equals 1. What did we start out with? Triangle JKL is equal to triangle J double prime, K double prime, L double prime. All right, so now let's look and see if we can do that without a graph. So what is the glide reflection that maps each of the following? So the very first thing I want to do is find my reflection. So for the reflection, we need the midpoint between the 2 points. So again, pick any 2 points. So I'm just going to do the midpoint with A and A prime. So -3 plus 1 cut in half, 4 plus 1 cut in half. So here we have -2, 2, 5, 2. So my midpoint is -1 and 5 halves. So now pick another 2 points, either B, B prime or C, C prime. I'm just going to go in order. So I'm going to do a B, B prime. And so my midpoint, I would have -4 plus 2 cut in half and 2 plus -1 cut in half. So here we get -2 halves, 1 half. So my midpoint, -1 comma 1 half. So now I need to find the slope of these lines. So my slope of those lines, so 1 half minus 5 halves over -1 minus -1. So on top, a half minus 5 halves leaves me with -4 halves over -1 minus -1 becomes 0. Anytime I have 0 in the denominator, my slope, this is an undefined slope. What kind of a line has an undefined slope? We know it is a vertical line. Remember, this is us on our bicycle staring down at that cliff thinking I'm not going down there. I'm undecided, so undefined slope. So vertical lines are all x equals something. So x equals, notice both of these had the same x value, -1. So we know it's a reflection about the line x equals -1. So my y values, my y value of A was at 4. My y value at A prime is at 1. So how far did I move my y values? From 4 to 1, I had to go down 3. So my translation is 0, -3 because I went down 3. Composition, reflection about x equals -1, triangle ABC equals triangle A prime, B prime, C prime. So this is our notes on how to find a glide reflection, classifying rigid motions. Your homework will be in Envision again, 3.4, and again you are still studying your vocabulary for your vocabulary test on Monday, and then our chapter test on Tuesday.